Right. So today we are going to discuss about enthalpy and price of bread. What? Let's see what's happening there. Now, these are two different years, right? These are two different. In 2019, a person pays 100 for purchase some amount of items, and for the same items, he pays 107 in year 2020. That means it has been increased. The price of the good has been increased by 7. So we know this one as inflation. So increasing price of goods and services, we call it inflation. But in Sri Lanka, we don't understand it. If you ask from the normal people, do you get it? No, they won't get it. But our politicians, they do something smart. They tell the same thing in a different way. He says, when I was doing the government, bread was only 50 rupees. But with the new government, it's 7 rupees. Our people get it. Our people get it that it's really hard to live because the price of goods and services being increased. But you know one thing, inflation is not equal to price increase in bread, but inflation represents the price increase in bread. If you have greater inflation, the increase in price in bread will be greater. So, if you take a chemical reaction, some chemical reaction, they will release energy while they are taking place. Some chemical reactions, they will absorb energy while it takes place. Let's see how we can perform a reaction in a laboratory. You can perform the reaction in two ways. One is performing the reaction under constant volume. That means we have a fixed container. We are going to perform the reaction. So when the energy is released during this reaction, the whole amount of energy will convert as a heat change. So therefore energy change of the reaction is equal to heat change. But if we perform the reaction under constant pressure, what will happen? When the energy released from the reaction, some amount of energy is used to increase the volume. That means there will be a work done. And some amount of energy is used as heat. So what will happen? The energy change is equals to work done to increase the volume of the system plus heat change of the reaction. So which means that if you have performed the reaction under constant pressure, energy change is not equal to heat change. So if you want to perform these two reactions in a school lab, one is constant volume, other one is constant pressure. Constant volume one we cannot perform in a school lab. Why is that? If you perform a reaction in a constant volume, technically we are creating a bomb. So therefore, let's see whether we can perform the reaction in constant pressure. Of course, it's easy. The reason is most of our reactants are aqueous solution. When you mix two aqueous solution, the only pressure on top of that solution is atmospheric pressure. So all the aqueous reactions, what we are doing, performed under constant pressure. But remember, when you perform the reaction under constant pressure, energy change is not equals to heat change. But it's like inflation. The greater the inflation, greater rise in price of bread. So inflation is not equal to price rise increase in bread, but it represents the price increase in bread. Same way, when you perform the reaction under constant pressure, energy change is not equals to heat change, but energy change represents the heat change. Greater energy change means greater heat change. So if you perform the reaction under constant pressure, we can't call heat change as energy change because they are not equal. So therefore we give a new term. The new name given for this heat change is known as enthalpy change. So remember, when you perform a chemical reaction under constant pressure, the heat change of the reaction is known as enthalpy change. Thank you very much.